Hello students, hope you are doing well. So in the last video we studied about the classification of colloid. So today we'll start with preparation of colloid. Now there are different types of methods for the preparation of colloid, like chemical method, mechanical method, electrical method. So today we'll first start with chemical method. So under chemical method, again, there are different types of process like double decomposition, by reduction, by oxidation, or by hydrolysis. So in double decomposition, we will take two substances like AS2O3 and H2S. Both will break. That means both will undergo decomposition and they will form a new substance. So AS2O3 plus 3H2S. So AS will take sulfur from here and will form the colloid AS2S3. Now if you have like confusion, how is the reaction taking place, just focus here positive and negative. AS being positive, will go for the negative part, that is sulfur. Oxygen being negative, will go for the positive part, that is hydrogen. So AS positive with negative sulfur forms AS2S3. Oxygen negative with positive hydrogen forms H2O. Next method is by reduction. So here AuCl3, the oxidation state of Au is plus 3. So it is reduced. Now we know oxidation and reduction, they are defined and based on different factors. Like oxidation is addition of oxygen, removal of hydrogen, or is also the tendency of losing electron. So if you lose electron, is known as oxidation. If you gain electron, is known as reduction. So here Au with 3 positive forms Au, that is gold salt. So plus 3 to 0. So this is reduction. So this is how the colloid, the gold salt, is formed by reduction method. Similarly here by oxidation, sulfur here is 2 negative. So from S2 negative to S, it is formed by losing electrons. So is oxidation. Hydrolysis. Hydrolysis means breaking of water. So FeCl3, Fe3 positive will take OH negative from here, will form FeOH whole 3. So this colloid is formed by hydrolysis method. So these are the chemical methods by which we can prepare colloid. Next, let us see how to prepare colloid by brick arc method. Brick arc method. In this method, we take water. The water here will act as dispersion medium. The water is kept at a low temperature. So we'll take a container with ice and then we'll put the container containing the water in a bucket of ice so that the temperature is low. Now I'll explain the importance of taking ice here later in this process. So we have water here in the container and we take a metal rod. So if you are going to prepare gold colloid, you will take this metal gold. If you want to prepare silver colloid, you take this as silver. Now one end is connected to the positive end, will act as anode. This is connected to the negative end, will act as cathode. So at a very high voltage, the metal will vaporize. At a very high voltage, the metal will vaporize. That means the metal will come out in a gaseous form. Now, the gaseous form, there is a possibility that the gaseous form, the gas may escape. So that's why to convert the gaseous form of gold to a solid salt, we need ice. That means to convert the gaseous form, that means for the condensation process, we need to keep the temperature low. That's the reason we need ice. Now, the second problem here, in the container, this gold particle, which is in the colloidal range, they may come close and form an aggregate. So to avoid this, we'll add potassium hydroxide. Now when we add potassium hydroxide here, this gold particle will be surrounded by hydroxyl ion. So when they are surrounded by hydroxyl ion, they are negatively charged. So similarly, the other gold particle also will be surrounded by which negative? So now in this case, the colloidal particle will not be able to come closer because they will be repelled by the negative charge carried by the hydroxyl ion. So first point, when on applying high voltage, when it vaporizes the gold, we have to condense it, and for that we need ice so that we can keep the temperature low and the vapor phase is condensed to solid form. Next, so that the colloid, the gold particle, they don't come close and form aggregate, we'll add here potassium hydroxide. So the gold particle, which is in the colloidal range, with water as dispersed phase, will form colloid by brick arc method. Well, the next method for the preparation of colloid is peptization. In peptization method, we have to take freshly prepared precipitate, potassium hydroxide and water. This is a very simple method. In a tube, you take the freshly prepared precipitate, you take water, and you take potassium hydroxide. You mix it well, so the resulting solution will be colloid. So colloid is prepared by peptization method simply by mixing the freshly prepared precipitate, potassium hydroxide and water. So these are the three methods by which we can prepare colloid. That is by chemical method, by brick arc method and by peptization. Next, we study the properties of colloids. So the first property is colligative property. Now, colligative property is a property which is dependent on quantity, not on quality. It's simply dependent on the number of particles, irrespective of the nature of the particle. Like say if you take a colloidal solution, the properties of the colloid is purely dependent on the number of the particles. It's not dependent on the nature of the particle. It doesn't matter whether it's strong or weak, whether it's force of attraction is there or force of repulsion is there. It doesn't matter. It's simply the quantity, the number of particles. So that's why colloids have colligative property. And they are also heterogeneous in nature. That means there are different sizes of particle present in the colloid. Though the heterogeneous nature, it cannot be seen our naked eye, but if you observe it through a microscope, you will see it's heterogeneous in nature. Next property is Tyndall effect. So in Tyndall effect, you take a colloidal solution. If it's light ray, the sunlight, if it passes through the colloidal solution, the light ray will scatter. So this scattering of light in colloidal solution is known as Tyndall effect. This is due to the heterogeneous nature of the particle in the colloidal solution. Now, why the scattering takes place? Let us see. So this is a colloid particle. Now, when the light ray strikes this colloidal particle, the colloidal particle will scatter the light ray. Now again there will be more colloidal particle in the solution. So this particle again will scatter this light in different direction. So this is how it continues. So in simple word, if you say Tyndall effect, it is the scattering of light by a colloidal solution. Next property is Brownian movement. So we know in a colloid we have two components, dispersed phase and dispersion medium. Now the particles of dispersed phase moves in a zigzag motion. It's like this, zigzag motion. So this zigzag motion or the movement of the dispersed phase particle in the colloidal solution is known as Brownian movement. Now when the dispersed phase particle is bombarded, this particle, if it's moving in this direction, will strike this dispersion medium particle, will change the direction. So it reaches here, again strike this particle, changes the direction, strike this particle, again changes direction. So you can see there is a possibility of a zigzag motion. So this zigzag motion is known as Brownian movement. Next is charge. The colloids, they are charged particles. They will carry either positive charge or negative charge. That means they are either positively charged or negatively charged, depending on the nature of the dispersion medium. Next property is electrophoresis. So in this method, this electrophoresis property of colloid, it proves that the colloid is a charged particle. So this is a U-shaped tube. We have the colloidal solution here. Let us take a platinum electrode here, which is positively charged, and a platinum electrode here, which is negatively charged. So this is anode, this is cathode. Now, depending on the charge of the colloid, say if the colloid is positively charged, if the colloid particle is positively charged, it will move toward the negative electron. But if the colloid particle is negatively charged, it will move toward the positive electron. So this movement of the colloid particle toward the oppositely charged electron is known as electrophoresis. Next, we will study the purification of colloid. So there are three important methods which is used for the purification of colloid. First is dialysis. So in dialysis method, we use a cellophane bag. Now this dialysis method can be used for the removal of crystalloid, for removal of HCl from the colloid. So in this method what we do, we take the impure colloid in a cellophane bag. And the property for the purification of colloid in this method is diffusion. So colloid particles, they don't have this diffusion property. So that's the reason we can use this for the purification of colloid. So we take the impure colloid in a cellophane bag, and this bag is suspended in fresh water. Now when the cellophane bag containing the impure colloid is suspended in fresh water, the impurities will easily diffuse out of this cellophane bag. Whereas the colloid particles remain inside the bag. Now you have to be careful here. You have to keep changing the water frequently, because if you keep it for a longer period of time, the impurities may go back into the bag. So it's very simple. You take the impure colloid in a cellophane bag, suspend it in the water, fresh water, the impurities will diffuse out and the colloid will remain inside the bag. So this is the dialysis method for the purification of colloid. Next method is electrodialysis. Electrodialysis. Now dialysis process is very slow. So what we do, to increase the speed, we take a positive electrode and a negative electrode, kind of electric field. So in presence of this field, the process will be faster. That means the process of dialysis will be faster. This process is known as electrodialysis. The third method is ultrafiltration. Now you know the normal filtration process. It's nothing different from that, but it's just that we use a special type of filter paper in this filtration process. The filter paper is known as ultrafilter paper. Now this ultrafilter paper is prepared by soaking filter paper in a solution of 4% nitrocellulose. 4% nitrocellulose solution mixture of alcohol, ether. So we take a mixture of alcohol and ether, and in that solvent we'll prepare a 4% nitrocellulose solution, and there we'll dip the normal filter paper. We'll keep it overnight and then we'll dry it. So after that, the filter paper we get is known as ultrafilter paper. Now it's very simple. You take a funnel, ultrafilter paper, impure colloid. Now the ultrafilter paper, how is it effective? When we prepare this ultrafilter paper, the size of the pores in the filter paper is reduced. The size of the pores is reduced,